Okay, I'm going to make a short video showing how I work through one of these worksheet problems. Hopefully this will give you a start and help you think about the other problems on the worksheet. So I'm looking at 3A. If K equals 0.022 reciprocal seconds for a first order reaction, what will be the final concentration after 30 seconds if the initial concentration is 0.1 molar? Okay, well it tells me it's a first order reaction, and so that should bring to mind a certain set of equations that might allow me to relate time to final and initial concentrations and the rate constant. The one I like the best is the one that can produce a line, so if I ever need a slope I can think about doing that to determine a rate constant. And so I'll look, and I'm probably going to start by just writing down this first order applicable equation. And if I look at it, it's got pretty much everything I need in here, right? It's got the rate constant, which is given. It's got time, which is given, 30 seconds. It's got initial concentration, which is given. And then the only thing that is not given is the final concentration, which is what I'm asked for. And so from now on, it's just simple algebra where I can plug in these things. Ln concentration of A to the T, that's what I'm asked for, equals negative 0.022 reciprocal seconds times 30 seconds. Here it's good to make sure that your units are matching up. You know, if your rate is in reciprocal seconds, then the time that you should be talking about should be in seconds also, so that they can cancel out. Plus the ln of the initial concentration, which is in molar. There we go. Okay. Now, if I get out my calculator, I can start working through this thing. You see that? Yeah. Okay. So, ln concentration at 30 seconds equals negative 0.022 times 30, negative 0.66 plus the ln of 0.1 molar, so negative 2.30, and I'm going to put in a bunch of sig figs here and then just keep it at the end, 259. Okay, and actually I'm going to keep those in the calculator and just subtract 0.66. So now I can say ln the final concentration at 30 seconds equals negative 2.96259. Right. Now how do I solve for the final concentration? How do I get rid of this ln? Well, on my calculator it's the second function of ln e to the x. So if I take the e of both sides, then what I'll be left with is concentration of A T, and here I'll do it, I'll say e to the x of my answer equals 0.0, and here's where I'm going to pay attention to the sig figs, and I'm really only given 2 in the problem, so I'll say 5.2, and the units are in molar, and that's my answer. It better be positive, right, because we're talking about a concentration, and we would imagine it would be less than 0.1 molar since that reaction has a positive rate constant. All rate constants are positive, and we're letting it go for 30 seconds. So things look good.